Hi everyone. Today we're going to discuss in this short video what is a group analysis and how do we separate these chemicals using different chemicals with concentration gradient. Let's say you have a mixture or bucket of cations. In a mixture you have plenty of cations. Let's say 25 to 30 amount of cations are there. Then we're going to separate them one by one going with this concentration gradient. Okay, let's say if you done only inorganic chemistry, if you don't have this solubility product theory knowledge, you would not understand this. How do we go with the solubility product? So I'm going to leave that side aside. I'm just going to explain this one, just considering you guys have done only inorganic chemistry, unit 6. Okay, so let's say we have a mixture of cations. Let's say here we have a mixture of cations. Inside this mixture, let's assume that there are lots of cations are there. So we're going to go with the concentration gradient. Cations which need a very low concentration of anions are precipitating first, and the cations which need higher concentrations are getting precipitated later. So that I'm going to start from the one which need very low concentration. So initially to the medium I'm adding dill HCl. I'm adding dill HCl. Then it's dill HCl. So the chloride concentration is really low. So cations who need very low chloride concentration getting precipitated. So that here silver plus mercurous and lead are getting precipitated. So whatever the compounds getting precipitated, we are putting them as group 1. Group 1. See, there are 3 cations are precipitating. So we keep that all as group 1 and we leave it aside. And then we filter the mixture so that the precipitation has these 3. So we have separated only these 3. Then the filtrate has all the other cations. So we are moving to the next step with the filtrate. In the filtrate, there are all these other cations. What do we do? So through the filtrate, we are passing or we are bubbling H2S. We are bubbling H2S. Then, couple of compounds, couple of cations who need lower sulfide concentrations are getting precipitated. So when you are adding H2S, compounds who need lower concentrations are getting precipitated here. Okay, so all these need lower concentrations of sulfides are getting precipitated. So we separate them and we name them as group 9, and you guys can, group 2 and you guys can see there are 9 cations precipitating under group 2. Okay, that part also is done. Here we done that part as well. Then again to that filtrate we filter, we separate the precipitate and we name them to group 2, and then we are moving on to the next filtrate. To that filtrate we are adding, we are heating. Why we are heating? Because we don't want this excess H2S in the medium. It can go through these redox reactions, and if it makes sulfur, it makes the solution turbid or the clarity is disappearing. So that to avoid those, we need to remove H2S. For that, we are heating. And then, the next step is adding conc nitric and heating. Why we are adding conc nitric? So, in this solution, if let's say we have Fe2+, Fe2 plus need more hydroxides to get precipitated as ferrous hydroxide. But if you use higher concentration of hydroxides, not only these group 3 elements, all the other rest of the elements happen to get precipitated. To avoid other cations getting precipitated, to limit couple of cations to get precipitated, to remove Fe2+, to oxidize Fe2+ to Fe3+. Here we are using Fe3+. we heat this solution with nitrate. We heat the solution with nitrate. Okay, that's the second step. And then the third step, we are adding ammonium hydroxide. Why we are adding ammonium hydroxide now? We're going to precipitate these cations as hydroxides. Why we are adding ammonium chloride to the mixture? Not only this, we are adding ammonium chloride. Why we are adding ammonium chloride? Ammonium chloride makes the ammonium hydroxide concentration less. Ammonium chloride makes the hydroxide concentration in the medium less. Okay, so to make this hydroxide concentration less, which supports only to precipitate compounds which need lower hydroxide concentration, we are adding ammonium chloride to the medium. So, better explanation comes under equilibrium. Assuming that you guys have not done equilibrium yet, I'm going to go only through this inorganic chemistry knowledge. Okay? So, whatever the precipitations you get, you separate them. You name them under group 3, and remember you have only 3 cations coming under group 3. Again, you separate, you filter, then get the filtrate, keep the precipitation out, then you are going to group 4. So at group 4, what do we do? Now, again we are passing H2S. So when you are passing H2S, now the concentration of H2S is increasing by the basic medium of the medium. So when you are adding ammonium hydroxide to the medium, it is increasing the sulfide concentration of this H2S, so that these guys, these cations who need higher sulfide concentrations are now precipitating here. That is the group 4. Filter, separate the precipitate, and then you are getting the filtrate. So you are going to the next group. Next group is the group 5. So you are heating again, the same reason here. You are heating again here. Why? Because you want to remove H2S. And then you are adding ammonium hydroxide. Why? Because you want to give the basic condition. To that you are adding ammonium chloride. Why ammonium chloride? Because you want to decrease the hydroxide concentration. So the ammonium hydrochloride as well. Then we need to precipitate these guys as carbonates. To precipitate these cations as carbonates, we are adding ammonium carbonate. See, once you add ammonium carbonate, these calcium, strontium and barium are getting precipitated. So we separate them to group 5. Actually, there are 3 compounds in group 5. Then we are moving to last group. So these are really harder to precipitate. You guys know, like, if you know the separately, group 1, these elements are really harder to get precipitated, and magnesium needs higher concentrations of whatsoever. Usually we consider all the ammonium salts are water soluble, so that these are really hard to precipitate. So what do we do is, so we separate this filtrate, so we can use some other, for sodium we can use this flame test, potassium flame test, magnesium we can use 8-hydroxyquinone. So on there are other methods. Ammonium salts we can use any strong base. So likewise you can identify these groups. Again, if I go with what are these elements you are getting precipitated, these cations. From under group 1, you have silver, mercury and lead. All these are having white precipitate, white color. If you are moving to the second one, so lead, copper, bismuth and sulfur, mercury. Lead, copper, bismuth, mercury, sulfides, they are black color. Arsenic, tin, 2+ and cadmium, yellow color. This is tin 4+, this one. This is tin 2+, and antimony, they are having brown and orange color. You're supposed to memorize these colors. Moving to group 3, ferric, red brown, aluminium white and chromium green. Under group 4, zinc sulfide white, manganese sulfide pink, cobalt and nickel black. Under group 5, all these three cations, calcium, strontium, barium, they are having white color precipitates. Okay, so this actually is not done here. This is continuing equilibrium, the 12th unit. To understand this better, why only these are precipitating? Let's say here H2S and here H2S. How come these cations are not precipitating under second group? Those information are coming under unit 12 equilibrium once you understand the principles of solubility product. Okay, to understand this one, I guess this knowledge would be enough for you. This part is coming only under inorganic chemistry, group analysis of inorganic compounds.